The vast expanse of space, often perceived as empty and dark, is actually teeming with incredible activity. It is within these seemingly desolate regions that the universe's most fascinating spectacles unfold. Among them is the birth of stars, a process that begins in colossal clouds of gas and dust known as nebulae. These nebulae, often spanning hundreds of light-years across, are the cosmic cradles of stars. Imagine a cold, dark cloud of hydrogen and helium, remnants from the Big Bang itself. This is a nebula. Gravity, the architect of the cosmos, gradually pulls these scattered particles together. As the cloud collapses under its own weight, it fragments into smaller, denser clumps. These clumps, destined to become stars, continue to contract, their cores becoming increasingly hot and dense. The Eagle Nebula, with its iconic pillars of creation, provides a breathtaking glimpse into this stellar nursery. These pillars, towering light-years high, are sculpted by the intense radiation of newborn stars. Within these dusty structures, countless stars are igniting, their light struggling to escape the surrounding gas and dust. These stellar nurseries are a testament to the continuous cycle of birth and death that governs the cosmos. As the dense clumps of gas and dust within a nebula continue to collapse, they heat up dramatically. This intense heat causes the atoms within the clump to move faster and collide more frequently. This stage marks the birth of a protostar, a celestial object on the verge of becoming a star. The protostar, radiating heat and light, is still shrouded in its cocoon of gas and dust. Gravity continues to pull material inward, increasing the pressure and temperature at its core. After millions of years of this cosmic dance, a critical threshold is reached. The temperature and pressure at the core become so intense that nuclear fusion ignites. At this crucial moment, hydrogen atoms, the simplest and most abundant element in the universe, are forced together under immense pressure. This fusion process creates helium, a slightly heavier element, and releases an incredible amount of energy. This energy, in the form of light and heat, is what makes a star shine. The protostar, having achieved nuclear fusion, officially graduates to the status of a star. With the ignition of nuclear fusion, a star enters the longest and most stable period of its life, the main sequence. Our Sun, a typical main sequence star, has been in this phase for about 4.6 billion years, and is expected to remain so for another 5 billion years. During this phase, a delicate balance is maintained within the star. The outward pressure generated by the energy released from nuclear fusion in the core counteracts the inward pull of gravity. This state of equilibrium, known as hydrostatic equilibrium, prevents the star from collapsing under its own weight. It is this balance that allows stars to shine steadily for millions or even billions of years. The color and brightness of a main sequence star are determined primarily by its mass. More massive stars burn their fuel much faster, leading to higher core temperatures and a bluish-white hue. Less massive stars, on the other hand, burn their fuel more slowly, resulting in cooler temperatures and a reddish color. Our Sun, with its yellowish-white color, falls somewhere in between. Stellar evolution. Red giants and white dwarfs. As a star ages, it gradually exhausts the hydrogen fuel in its core. This depletion of fuel disrupts the delicate balance between gravity and nuclear fusion. Gravity begins to gain the upper hand, causing the core to contract and heat up even further. This heating of the core has a profound effect on the outer layers of the star. They expand dramatically, causing the star to swell up to hundreds or even thousands of times its original size. As the star expands, its surface temperature cools, giving it a reddish appearance. This marks the transition to the red giant phase. For stars like our Sun, the red giant phase is a prelude to their eventual demise. As the core continues to contract, it eventually reaches a point where it can no longer support nuclear fusion. The outer layers of the star are then gently puffed off into space, forming a beautiful, expanding shell of gas known as a planetary nebula. The core, now exposed, cools and fades, becoming a white dwarf. Cosmic cataclysm, supernovae, and the birth of stellar remnants. Massive stars end their lives dramatically. After exhausting their fuel, they collapse and explode as supernovae. These explosions forge heavy elements and scatter them into space. The core becomes incredibly dense, forming either a neutron star or a black hole. From stellar birth to explosive endings, stars shape the universe. but there's still so much more to explore. Don't stop here. Watch more space mysteries. Subscribe now for more cosmic journeys.